Hello everyone, here is a question from quantum mechanical model of atom. Heat treatment of muscular pain involves radiation of wavelength of about 900 nanometer. Which spectral line of hydrogen atom is suitable for this? We know that energy is equal to hc by lambda. For an hydrogen atom, the energy for a nth stationary state is equal to minus Rydberg constant times z square divided by n square. Z is the atomic number and n is the value of the stationary state. For hydrogen atom, we know that z value is equal to 1 because the atomic number is 1. We have only one electron. In the hydrogen emission spectrum, we basically calculate the energy difference, isn't it? Initially, the electron is in the ground state. We eliminate with a photon of some particular frequency, and then electron goes to the excited state, and then it either comes back to the ground state or to a low lying excited state. Depending upon where it is coming back, we have different series. If n equal to 1 means that is Lyman series, n equal to 2 means that is Balmer series, n equal to 3 means that is Parsons series, 4 means bracket series, and then 5 means Fund series. So, depending upon where it is coming back, these values are n2 values and these values are n1 values. So, it is the energy difference that we calculate in the hydrogen emission spectrum, and therefore, delta E is equal to En2 minus En1, and therefore, this is equal to minus Rydberg constant times 1 by N2 square minus 1 by N1 square, or we can also write it this way: Rydberg constant times 1 by N1 square minus 1 by N2 square. Basically, what we are doing here is we are comparing energy with the energy difference. So, hc by lambda is equal to hc by lambda 2 minus hc by lambda 1, and that is equal to Rydberg constant times 1 by n1 square minus 1 by n2 square. So, hc is common, and therefore, let us take that out. Therefore, we can write that 1 by lambda is equal to Rydberg constant times 1 by n1 square minus 1 by n2 square. Therefore, 1 by lambda times Rydberg constant is equal to 1 by n1 square minus 1 by n2 square. Lambda is given as 900 nanometer, which we can write it as 10 to the power minus 9, 900 times 10 to the power minus 9 meter. Rydberg constant is given as 10 to the power 5 centimeter inverse, and we know that 1 meter equal to 100 centimeter, and therefore, let us convert this meter into centimeter. Therefore, if we do that, then 1 by 9 times 10 to the power minus 7, because we have 10 to the power 2 here. So, this will become minus 7. So, minus 7 meter times 100 centimeter divided by 1 meter times 10 to the power 5 centimeter inverse. Therefore, this will become 10 to the power minus 5. So, 10 to the power minus 5, 10 to the power plus 5 will cancel, centimeter inverse, centimeter will cancel. Therefore, what we will have is simply 1 by 9. Therefore, 1 by 9 is equal to 1 by n1 square minus 1 by n2 square. Now, if the n2 value is equal to infinity and the n1 value is equal to 3, then we can equate this, isn't it? 1 by 9 will be equal to 1 by 9 in that case, because 1 by infinity square we can consider it as 0. Therefore, Parsons series option 1 is the correct choice here.